Hello, this is Timothy with Growling Pigeon Studio. Recently, I had an experience. I was interviewing for a senior .NET developer position for a nice company. And when I got there for the job interview, they wanted me to do a string reverse. Basic, simple setup, like you see on the screen now. They typed in "Hello, Timothy" because they wanted to be personable, and so said, "All right, reverse "Hello, Timothy" using Linq." Okay, well that's easy. So to do that, we return s. We need to turn it into a character array. If I can type it right, so 2-character array, and then we reverse that using Linq. Then, if I didn't understand Linq well, I would say, all right, cool. I've got a reversed character array. I can do new string. So let's do that now. New string reverse. That doesn't work, and then I would scratch my head and think, well, why? Well, it's because it returns an IEnumerable. It's a deferred execution. So I actually have to convert it back into an array. You may think, well, why not just do toString after the reverse? It's not going to give you quite the result that you expect. So this will work. I run it, and I get my reverse string. "Hello, Timothy." Cool. So when I was in that job interview, I said, well, I can do it faster. And so I did. Or at least I began to. And I'll just copy over what I did. And I'll talk you through it real fast. So basically, I use an unsafe context, and in order to use unsafe, you need to actually go into your project, go to Properties, Build, and then go to All Configurations, Allow Unsafe Code. Save that, and then we're back in business. Okay, so I've got my unsafe context, and I'm taking in a string s. I copy it to string reversed. I get the pointer to the beginning of the reverse string, which is the copy of s. I get a low and a high, which are the beginning and end of the string, and then I iterate while they're converging, but not past the point of convergence. And here's them converging, and I just do a simple swap using a holder variable, and then return reversed. And, well, if I test that out, so instead of Linq reverse, we'll do fast reverse. I'll prove to you that it works as expected. Just a second. "Hello, Timothy." Perfect. Alright, so I say that what I have done is faster. Do I have any way of backing that up? Well, yeah. I created this other class called CycleTimer. It takes in its constructor some cycles. Save that off. And then I can do time action. I can do some warm-up cycles so that everything is loaded up into the L1 cache. We don't have to worry about any cache misses as we're doing our test. And we just iterate through the number of cycles and perform our action and stop the timer, and that will return the elapsed milliseconds. Okay, cool. So I said it was going to be faster. How much faster? Well, let's copy over my pre-made code. I feel like I'm in a kitchen. Here's my pre-baked loaf of bread. If you ever remember those shows, late night TV. Okay. So just really quickly, I've got cycles, 1 million cycles. Got a timer, which is my cycle timer class. I put in the 1 million cycles. I do Linq reverse first, and then I do fast reverse. Same string on both of them. "Hello, Timothy." We're going to get the difference, which is going to be the number of times faster that fast time is compared to Linq time. Because these are going to give us some numbers that aren't going to be as easy to just do immediate arithmetic in your head. And why do that when you can make the computer do it? So let's run. And here are our results. Look at that, 7.5 times faster. That's amazing. 46 milliseconds compared to 346 milliseconds. So yeah, this is definitely faster than Linq. So why is that? Why is doing all of this code, which is ugly, it's hard to read, and let's be frank, nobody's going to want to maintain this. You know, this is not easy to maintain. Why is this so much faster? The answer is that we are avoiding as many memory allocations as possible. Now, we can avoid one more memory allocation, and I'll talk about that real fast, or soon, but first we'll talk about this. So we have, in our Linq reverse, we have our incoming string. We copy that to a new character array. So we copy all the characters into a new character array, so that's a memory allocation and a copy. Then we do a reverse using Linq. Now, with Linq is actually slower than you might think. It's really fast, don't get me wrong, but I can consistently write code that is faster than Linq statements. The reason that we use Linq statements is because it's easy to read, easy to maintain. All right, and then we have our to array, which is actually a part of Linq as well, but is going to do another memory allocation. So we have two character arrays now, and this is going to be our reversed character array. Then we create a new string based off of that new character array. So our second character array that we just created with the to array, we're going to now create a new string, so that's another memory allocation. So that's 3 memory allocations. Count them. 2 character array, 1. To array, 2. And then new string. That's 3 memory allocations. The reason this is so much faster is because we only have 1 memory allocation. We create the string reversed of S. It's a copy of S. We can make this even faster if we're okay with side effects. So if we're okay with the string S changing after our reverse, then we can just say, all right, we're going to do S, we're going to do S here, and get rid of reversed. All right, let's run that. So it was 7.5 before, right? 7.5 times faster. Let's see what this is. 18.6 times faster. Look at that. So anyway, this has just been a little demonstration about string reversal and memory allocation. When you're writing video games or you're writing back-end logic for a server, it's a really good idea to think about how fast your code is going to be. Usually, a string reversal, that's kind of, whatever. But it's a silly example. But yeah, it's a really good example to demonstrate how memory allocations can really hurt performance, and how strings in general are just really bad for performance. As far as the readability and maintenance, with fast reverse, I would give this a new name, like string reversal or reverse string. I would make sure it does not have side effects. So we're going to still, do our memory allocation, and then we'll do reversed down here. Let's copy that back down, and so I'd have a string like that. I'd have a method like this, and I'd rename it something easy to understand and to understand what it's doing. And I'd write a bunch of unit tests around it to make sure that its behavior is well documented. That way, other programmers, they can look at the code and go, oh, but then they can look at the unit tests and hopefully understand that they don't have to look at my code because my code is nice and solid and secure. Cool. Well, anyway, thank you very much for taking the time to listen to me just jabber, and I hope you have a great day. Bye.